Hello and welcome friends. In this video we see proof of Cauchy's test for improper integral and absolute convergence. The intent of Cauchy's test is the improper integration of f converges at f at a if and only if to every epsilon greater than 0 there corresponds a delta greater than 0 such that mod of integration of a plus lambda 1 to a plus lambda 2 is less than epsilon for 0 less than lambda 1 comma lambda 2 less than delta. Now friend, remember the definition of improper integral. The improper integral having infinite discontinuity at point A is converges if limit lambda tends to 0 integration of a plus lambda to b of f exists and it is finite. That means we know that improper integration a to b f dx exist if limit lambda tends to 0 integration a plus lambda to b f dx exist and finite. If this is exist and finite, then we can say that the function this function if it is exist and finite, then it is a convergent. For example, we take 1 divided by x, and if we would like to integrate this 0 to 1, then if we take 0 plus lambda, then this is lambda to 1, and we know what is the integration of this. This is integration of log of x between the limit lambda to 1 and log of 1 minus log of lambda. Log of 1 is 0, so we have minus log of lambda. So when we take it as a plus lambda, this function will be converted as a function of lambda, and that is why we consider it as a capital F of lambda is equal to integration a plus lambda to b f into dx. So whenever limit of capital F of lambda tends to 0 exist and finite, the integral exists and it is said to be convergent. Okay. So it is a function of lambda. So whenever we said it is exist as lambda tends to 0, apply the definition of Cauchy's definition of limit. Therefore by Cauchy's definition of limit, what is the Cauchy's definition of limit? Whenever for epsilon greater than 0, given epsilon greater than 0, there exists delta greater than 0 such that for lambda 1 comma lambda 2 less than delta, whenever mod of f of lambda 1 minus f of lambda 2 is less than epsilon. Okay. So now see what is the f of lambda 1. This is integration a plus lambda 1 to b f dx minus integration a plus lambda 2 to b f dx, and this is nothing but this is whenever this is less than epsilon, and this is what? This is nothing but a plus lambda 1 to a plus lambda 2 f into dx less than epsilon whenever 0 less than lambda 1 lambda 2 less than delta. So when this condition is satisfied, the function is said to be convergence at point A, and this is due to by applying Cauchy's criteria of limit, and hence therefore it is called as a Cauchy's test. Theorem: every absolutely convergent integral is convergent. So what is meant by absolute convergence? When a function mod f is convergent, the function is said to be absolutely convergent function. And whenever that absolutely convergent function is convergent, absolutely convergent integral is convergent, then the integral is also convergent. Okay. So apply the Cauchy's criteria. What is given? Since it is given that integration of mod f, integration a to b, is convergent. If it is a convergent, we can apply Cauchy's test by Cauchy test. What is Cauchy test? For epsilon greater than 0, there exists delta greater than 0 such that mod of integration a plus lambda 1 to a plus lambda 2 of this mod function is less than epsilon when 0 less than lambda 1 comma lambda 2 less than delta. But we know that, friends, we know that in integration a plus lambda 1 to a plus lambda 2 f dx modulus is less than equal to integration a plus lambda 1 to a plus lambda 2 mod of f into dx. Okay. So, this is known to us. Then this is called this as a equation number 2. See the equation 1 and equation 2, this function. So, again this function is a positive, therefore we take modulus value of this. This implies this function is a positive, hence this is less than equal to mod of integration a plus lambda 1, or if depending on these values of lambda 1 and lambda 2, if we consider it it is a smaller and greater, this is mod f dx, right. Then you can see that equation number this is a less than epsilon, right. This is less than epsilon. Here we directly get the relation between epsilon and this one. Therefore, mod of integration a plus lambda 1 to a plus lambda 2 f dx is less than epsilon, and whenever this condition is satisfied, we say that by Cauchy's criteria the integration a to b f dx is convergent. So, this is about that every absolutely convergent integral is convergent. If function f is absolutely, integration f exists, integration mod f exists, integration of f is also exist. So, this is about the absolute convergence. Again, depending on this, we prove one problem where we see that how we can apply this absolute convergence to find or to show the integration of a function. For example, if we want to test the integration of the function 0 to 1 sine of 1 divided by x raised to p into dx. This function has an infinite discontinuity at point 0. So, what is f of x? F of x is sine 1 divided by x raised to p. Then mod of f is equal to mod of sine 1 by x divided by x raised to p, and sine 1 by x is always less than equal to 1. So, this is 1 divided by x raised to p. Okay. So, we have that is mod of f of x is less than equal to mod of 1 divided by x raised to p. But we know that therefore, the integration of 0 to 1 mod of f of x into dx is equal to integration 0 to 1, what is sine of 1 divided by x raised to p into dx. This is less than equal to integration 0 to 1 divided by mod of 1 divided by x raised to p into dx. But this integral is converges for which values? For p less than 1. Hence, therefore, this integration 0 to 1 mod of sine 1 divided by x raised to p into dx is convergent for p less than 1, and by absolutely convergence theorem integration 0 to 1 sine of 1 divided by x raised 1 divided by x divided by x raised to p into dx is convergent for p less than 1 and diverges for p greater than equal to 1.